Hello friends, welcome to our channel Metallurgy Crisp. In this video, we are going to discuss all 2-mark questions of GATE 2022 Metallurgy from 36 to 65. Friends, I scored 77 marks in GATE 2022 and I got All India rank 6. So I'm going to discuss all these questions with you in a short manner. I'm not going to take much of your time in a simple solutions I'm going to give. If you are still having doubts after looking at the solution, you can join our Telegram group Metallurgy Crisp. Here we can discuss any doubts that you're having regarding interviews of or your future. Friends, if you appreciate my efforts, please do like the video. So let's start the video. Friends, question number 36, we need to find the general solution of this differential equation. So the auxiliary equation for this equation is m square minus 4m plus 4 is equals to 0. So m minus 2 whole square is equals to 0. The roots are 2 comma 2. So if we have equal roots, general solution is in the form of c1 plus c2 2 times of e to the power of mt. Here m is our root 2. So friends, y is equals to a plus bt times e to the power of 2t. On expanding, we get our answer. Question number 37. Which of the following does not converge according to Newton reaction method? Friends, here we need to understand this method does not conserve when the denominator becomes 0. What happens, friends, when the denominator is 0? This whole function becomes infinity. So for which of the following functions f dash x is 0? This is what they are asking. So from the options, we need to find out at x is equals to half, which of the following function derivative becomes 0. So friends, first option is x times half 1 minus x is equals to 0, which is nothing but x minus x square is equals to 0. So the derivative of this function is x is 1, x square is 2x, so 1 minus 2x. So if we substitute x is equals to half, this becomes 0. So our first option itself satisfies the condition. So our answer is x times of 1 minus x is equals to 0. You can try for the other options as well, for which f dash x at x is equals to half is not equals to 0. Friends, question number 38 is a matching. This is a theoretical matching, so please refer to page number 110. And please remember, you need to mug up whole this page. Every year there must be some question from this page. All mineral beneficiation processes are being discussed in this page. So moving on. Question number 39 is magnetic moments. For diamagnetic, there are no dipoles, and para random arrangement of the dipoles, and ferro extremely unidirectional dipoles, and antiferro all these dipoles are getting cancelled. So they are exactly opposite. And for ferri, one side magnetic momentum is higher than the rest. So there is a partial magnetism. So from this concept, we can answer question number 39. Friends, question number 40. Before discussing, you need to know the slip direction in BCC is 111. It looks like in this, and for FCC, it looks like this. For FCC, these are the close back directions, so these are the slip directions. So friends, these are the three equations, three dislocation, dissociation or combination. These are all three are dislocation combination equations. We need to find out which belongs to which system. Friends, in the system, whenever you see 0, 1, 1, just now we discussed, this belongs to FCC. These all are dislocation directions. So these two, because of this direction, these two belongs to FCC, and these belongs to BCC. So just by looking at these equations, we can separate out which equations belong to BCC and FCC. And the second step is finding the energy of the dislocations, whether these dislocations are favorable or these equations favorable or not. If there is a reduction in energy, then only these equations are favorable. Sum of the energies of this dislocation plus this dislocation must be greater than this. Friends, if we calculate the energy of each dislocation, this is B1 square, this is B2 square, and this is B square. So this is 3 by 4, this is 3 by 4, and this is 1. Sum of these two is greater than 1. So this is energetically favorable. And this is BCC. From the options, we already got one option, friends. This is energetically favorable BCC. So this equation belongs to BCC. And if we go to Q, this is 6 by 36, 6 by 36, and 2 by 36. If we add these two, this is 12 by 36, and this is just 2 by 36. So this is also energetically favorable FCC reaction. And if you go to the third one, this is 6, 6, 12 by 36, and this is half. Here energy increment is there. So this is not energetically favorable, and this is unfavorable and FCC. So we got another option. Friends, Q is a very important equation. You need to remember this equation is the formation of Lomer-Cottrell lock. These two partial dislocations merge into form another dislocation which is not in the slip plane, which makes this dislocation sessile dislocation. So friends, if we look at the options, this is a typical dislocation in BCC, and this is our Lomer-Cottrell rock. This is energetically favorable, you can simply say that, and this is the one which forms in Lomer-Cottrell atmosphere, and the other one is unfavorable FCC reaction. Friends, 41 is another matching question. Quarter atmosphere related to the loader band. We know in our plain carbon steels, loader bands form when quarter atmosphere is there at 45 degrees to the axial direction. Friends, next Borslinger effect. This effect gives us the information about reduction in yield strength when the load direction is reversed. So while loading, it yields at a higher stress. If we reverse the loading direction, and it yields at a lower stress compared to this. So this is given by the Borslinger effect. Next, friends, Navarro-Hairpin creep. This is a deformation due to diffusion of atoms or vacancies. This is a stress-assisted diffusion. Deformation. Suzuki interaction is reduction in energy by segregation of solutes to the stacking faults. Friends, question number 42, given determinant of the matrix and the trace of the matrix, and one eigenvector is also given, we need to find the other two. So determinant is product of all the eigenvalues and the trace is sum of all the eigenvalues. So on substituting lambda is equals 3 is equals to 4, we get lambda 1 plus lambda 2 is equals to 4 and lambda 1 into lambda 2 is equals to minus 12. So from the options we can directly check this, or we can solve using lambda 1 minus lambda 2. We find lambda 1 minus lambda 2, from there also we can find, but directly from the options we get lambda 1 is equals to 6 and lambda 1 is equals to minus 2. Friends, question number 43, which of the following statements are true about black body radiation? Option number A, among all radiations emitted by the ideal black body at room temperature, the most intense radiation falls in the visible spectrum. This is what they have given, friends, but actually it is infrared radiation which falls in that region. So option A is wrong. And option B, they have given total emissive power of black body is proportional to square of the temperature, but actually it is e to the power of 4. So option B is also wrong. So if you go to third, the emissive power of ideal black body peaks at a wavelength lambda and is inversely proportional, which is inversely proportional to its absolute temperature. This is true, friends. Wayne's displacement, this law suggests this. If you draw emissive power versus lambda, you get a curve like this. It peaks at a certain lambda. And the fourth option is black body radiation, ideal black body radiation is always greater than that of non-black body radiation. This is absolutely correct, because black body is it releases maximum amount of heat than any other body. So option C and D are correct. Friends, question number 44. This is our setup. This is our consumable wire in the welding process. The question is, melting rate of consumable wire depends on what are the things? Friends, always remember, this melting depends on the amount of energy we are supplying. So first option is more heat, fast melting is obvious one. The more amount we heat, faster the rate of melting. And amount stick out length. Friends, stick out length is the amount of length of the electrode which is outside this. All the amount of heat release is there in this region. Electron comes, electron hits, here arc generation is there. So total amount of heat release is in this region. So if you increase the stick out length, you are increasing amount of material available in this region where heat is there. So the stick out length increases, more wire length is exposed to the heat. So rate of melting is high because more material is available there. And if you go to the diameter of the wire, so if you increase the thickness of the wire, what happens? You need more heat to melt the electrode. Friends, many people are confused with welding speed. Welding speed, why it is not affecting? Because welding, if you move or weld at this rate, or if you are moving the whole setup at some rate, there is no change in the amount of energy supplied here. So the melting rate only depends on these things and it does not depend on welding speed, because it doesn't have any effect on the total amount of energy supplied. So our answer is these three options. Friends, question number 45. So the flow is like this. This is an object, non-rotating, this is not moving. So flow velocity at point A is 0. This is obvious because flow cannot move beyond this. So what happens, friends? The flow comes like this, and on this line what happens? Velocity here is V and velocity V is 0. The flow comes and it envelopes the body and it moves like this. So the flow is again, the flow is like this. So if you look at the options, first option is velocity of the fluid at the point A is 0. That's right. And second option is we need to find the pressure at this point. Right. So if you apply Bernoulli's formula, both are at the same height, both points are at the same height. So for this point, if you apply half rho V square plus P, this point is PO is equals to, here velocity is 0. So it is 0 plus, and you can say PA. So pressure difference PA minus PO is equals to half rho V square. So option B is also correct. Third option is fluid moves perpendicular to OA. They are saying this. That is not the case, because fluid does not move like this. Fluid slowly, because it is steady and slow fluid, it moves like this. The fourth option is on each side of the central streamline OA, the flow will be deflated around the object. That is right, friends, because the flow is like this. Because it is slow and steady state, that is why it is following like this, friends. So our options A is right, B is right, and D is right. Friends, 46 is we need to find the strain rate parameter M. Sigma 1 and sigma 2 is given. Strain rate 1 and strain rate 2 are given. So just by taking the ratio, we get the answer. So if we take the ratio 50 by 70 is equals to 0.1 by 10 whole power n. We take ln on both sides, and by solving we get answer n is equals to 0.073. Friends, question number 47. Total pressure of the bubble is given by P outer and 2 sigma by R. Friends, here if it is a soap bubble, since both surfaces are exposed, it will be like 2 times 4 sigma by R. But here only one surface is exposed and the surface is covered by the metal and all. Hence we are using 2 sigma by R. So don't confuse here if it is 4 sigma by R or something like that. So friends, here every parameter is given. Outer pressure is given as 1.5 bars plus. So friends, let's substitute the given values. P outer is given as 50 and sigma is given as 1.4. Radius is 0.01 mm. So if you convert it, it will get 10 to the power of minus 5 meters. And since here what we get is pascals and we need to convert into bars, so we divide it with, now everything is in bars, friends. On solving this, we get 4.3 bar as our answer. Friends, 48, we need to find PCO by PCO2. We were given these equations. So this equation is given and this equation is given. We need to find a relation. Activity of this also given. So we need to find a single equation using these two equations. So to eliminate partial pressure of oxygen term from our equations, we multiply this equation with 2 and we reverse this equation. So we get this equation. Now we add this equation and this equation, which eliminates oxygen term. So friends, we get the final equation as this and delta G as this. From this, friends, we have equation delta G is equals to minus RT ln K. From this, we find ln K is equals to this, and in turn we get K is equals to 3.75. Friends, from this equation, we can write equilibrium constant of this equation is activity of this into partial pressure of CO whole square divided by activity of pure metal is 1, so it is 1, and PCO2 whole square. And we know K as 3.75. So since we need to find PCO by PCO2, let's say x is equals to PCO by PCO2. So this becomes x square. So activity of this into x square is equals to, we get this, and this in the question it is given as 0.5. So from this we get x is equals to 2.738, and this is our answer, PCO by PCO2. Friends, question number 49. We know delta G is equals to delta G naught plus RT ln K, and this is the equation. The cell represented is that this is the complete reaction of the cell represented in the question. So equilibrium constant of K is given by activity of PbCl2 divided by activity of lead. Friends, here lead is not staying as a pure element, so the activity of lead is given in the question because it is an alloy of gold and lead. So activities are given, partial pressure of Cl2 is also given. So substituting these values in that, we get K is equals to half. So from this equation, we get delta G naught is equals to delta G minus RT ln K. Delta G is nothing but minus N of E. E is also given in the equation. So minus RT ln half. Ln of half we can write minus ln 2. So minus and minus gets cancelled. So this is our final equation, friends. So substituting the given values in this equation, we get our final answer. Friends, let's substitute the value. N is equals to 2 because PbCl2 plus 2 and F is 96,500 and E given in the question. R is our universal gas constant 8.314 temperature and ln 2. On solving this, we get minus 232.88 kilojoules as our answer. Friends, for question 50, we need to find the spacing between the dislocations that form the tilt grain boundary. Friends, we have a formula tan theta is equals to Burgess vector divided by D. Here D is the spacing between the dislocations. Friends, here theta is just 2 degrees. When theta is very small, we can equate tan theta is equals to theta. So theta becomes B by D. We need to find out D, friends. D is equals to B by theta. We have theta, but we need to find Burgess vector for FCC. We're going to find that before that, friends. Since theta is in degrees, we need to convert into radians. Since 1 degree is equals to pi by 180 radians, so 2 degrees is equals to 2 pi by 180 radians. Now our aim is to find Burgess vector for FCC given lattice parameter. Friends, for FCC, Burgess vector is given by A divided by root 2, which is nothing but the magnitude of the closest back direction A by 2 into 110. On substituting A by root 2 in the place of Burgess vector, we get the final equation as this. Now we have all the values. A is given, theta is also given. So on substituting these values, we get our final answer. So friends, on substituting, we got this. This is given A and 2 pi by 180 is theta and root 2. So on solving, this we kept as nanometers only because the answer asked in nanometers. So our final answer is 2.9 nanometers. Friends, question number 51 is the most repeated question ever. Finding the desulfurizing index. Even the details given in the question are same, which have been repeating every time in many exams. Desulfurizing index is given by the ratio of weight percentage of sulfur in slag to that of metals. Friends, always remember when we use these brackets, this is for slag, an element in slag, and when we use square brackets, it is the element in metal. Friends, 100 tons of steel consists of 0.015% sulfur. So out of this, by doing, we get 15 kg of sulfur is there initially before desulfurizing using a special slag. So final sulfur is of 0.0025%, which is 2.5 kg. So the difference amount of 12.5 kg went into the slag. So friends, weight percentage of sulfur in slag is given by this. On solving we get 1, and for the metal we get this 1 by 400. So final desulfurization index is given by weight percent of sulfur in slag divided by metal, which is 400. Friends, question 52 is Minor's rule. We were given alternative stress, and at this stress, how many cycles the materials can undergo without failure, or the number of cycles for fatigue failure. Minor rule for damage accumulation says number of cycles occurred at a particular stress divided by maximum number of cycles it can accommodate at that particular stress. So if we repeat for different number of stresses and we summate them, it must be equals to 1. So let's look at the question. Friends, it is given that metal has undergone 5000 cycles at 400 MPa. At max it can go up to 10,000. So after this process they went to 25,000 cycles at 300 MPa. Here maximum can go up to 1 lakh, and they're asking what is the life at 500 MPa. So let's apply our damage accumulation rule, friends. This is Ni. So first 5000 divided by at 400 maximum is 10,000. So NF is 10,000 plus 25,000 at 300. So small m is 25,000 divided by at 300 maximum is 10 to the power of 5. We need to find out at x. So at maximum at 500 is 1000. So this is equals to 1. So this is 0.5 plus 0.25 plus x by 1000 is equals to 1. So on solving this, friends, we get x is equals to 250 cycles. So the life is 250 cycles at 500 MPa. Friends, for question number 53, we need to find the activity of gold. We know A activity of anything is given by gamma into xi, right? So we need to find gamma, and x is already given. So we have partial molar enthalpy formula as RTLM gamma A. Given partial molar enthalpy of gold is this, and mole fraction of gold is this. So by this we can say gamma of gold is equals to e to the power of h gold divided by RT. So let's substitute the values. So after substituting we get the value 0.49. So we need to find the activity of gold is equals to gamma gold and xi gold. So gamma gold is 0.49, mole fraction is 0.25. So this gives us 0.1225. This is our answer. Friends, for question number 54, we need to find the temperature at the interface. Since both are connected in series, heat flow rate through these two is same. So K delta T by L is same. Here the thickness is also same. So we can ignore this as well, which means K1 delta T1 is equals to K2 delta T2. This is material 1, this is material 2. So K1 of this material into delta T1 is 435 minus T. And similarly, K2 delta 2 is T minus 400. So given K1 and K2, K1 is 50, K2 is 200. So on taking K1 to that side, and this is 200, this is 50, gives us 4 times. So this is 435 minus T is equals to 4T minus 1600. On solving, we get the final answer. T is equals to 407 degrees. Friends, question 55 is finding R star. This is a straightforward, friends. 2 gamma by delta GV, and delta GV is equals to delta H delta D by Tm. So everything is given, friends. Under cooling is given as 10 degrees. So just by substituting these values, we get 25.53 nanometers. Friends, for 56, we need to find out magnitude of the flux. Flux J is given by minus D dc by dx. Friends, it is a vector. To be honest, we need to represent it by I cap, but we presume since it is unidirectional, we think this is in the x direction. So, but it is actually a vector. C is given as a1x square plus a2x, as a1 and a2 is equals to 1. RC is x square plus 1. So this will give minus d. Derivative of this is 2x plus 1. So let's substitute the given values. So friends, x is given 2 mm. We are not changing any units, friends, because the final units are also in mm. So on substituting, we get minus 15 into 10 to the power of minus 3. So it looks minus 15, but it is a vector. So the magnitude is 15 into 10 to the power of minus 3. So minus 3, 10 to the power minus 3 is already given in the question. So our final answer is 15. Friends, question number 57. We need to find out Cp by Cv given all the values. Here beta represents isothermal compressibility and alpha represents isobaric expansivity. We have the formula Cp minus Cv is equals to alpha square into temperature into V is molar volume divided by B. And here they said we need to assume it according to DeLong-Petit's law. According to this law, Cv is 3R. So friends, let's divide by Cv on both sides. So Cv by Cv becomes 1. Cp by Cv minus 1 is equals to, here we get divided by Cv. And since we know Cv is equals to 3R, we substitute that. Friends, now let's substitute all the given values. Friends, after substituting all the given values, we get 1.063 as our answer. Friends, question 58 is also a repeated one. 74 micrometer 200 mesh size is our standard sieve. If you can remember, that is also fine. Or else for the sieve size is 40 to 400. The value is almost product of aperture in micrometer into mesh number gives 14900 approximately. You can remember this as well to get approximate answer. Friends, 59 we need to find out the current. Heat supplied is equals to total heat and at what speed we are moving. The faster we move, less amount of heat supplied to that joint, to that place of the joint. So from this we can say speed is directly proportional to the current, which means if we have to move at faster speed, we need to increase current to give the same amount of heat. So just by speed 1 by speed 2 is equals to current 1 by current 2. So after substituting the given values, we get I2 as 220. Here voltage is constant. Friends, work done in extrusion formula is given by K epsilon for n plus 1 by n plus 1. Here epsilon is ln of R and R is extrusion ratio. Extrusion ratio is A0 by AF. So let's find A0 by AF is nothing but diameter square divided by final diameter square. Friends, diameter is given as initial is 30, final is 20. So D0 by DF square is given by this 2.25. So our strain is epsilon is ln of 2.25. And given this equation, sigma is equals to K epsilon power n. So from this we get K is equals to 350, n is equals to 0.3. Now we have all the values. We have K, we know epsilon, we have n. So let's substitute all the values to get the final answer. So friends, after substituting the value, this is 350 megapascals. So here we get megajoules, which is nothing but 205 into 10 to the power 6 joules. This is our answer. Friends, question 61 is trapezoidal rule. The integral is given by h by 2 into first term, the last term, and 2 times of the remaining terms. Given function is this, and here they said only single segment. So final term minus initial term divided by total number of segments gives us the h value. So here h is equals to 1 and x0 is equals to 0 and x1 is equals to 1. Now we need to find h0 and hn by substituting these values in the given function. Friends, h0 is nothing but f of x0, which is nothing but f of 0, which is 0.2, and h1 is equals to f of 1, which is 10.2. So after substituting this formula, since there are no more extra terms, we won't use this. So 1 by 2 into 0.2 plus 10.2 gives us the answer 5.2. Friends, question number 62. Here air at 300 Kelvin is passing and leaving at 600 Kelvin. And the surface of this tube is kept at constant. So we are taking T infinity, which is 700 degrees Kelvin. We need to find out length of the tube. Friends, here we equate heat lost by the metallic tube is equals to increase in internal energy of the gas. So heat lost, convective heat loss is a flow of some fluid. So minus, because it is losing heat, HA delta T is equals to mCp dt by dt, dt by dt. So let's rearrange these terms and let's take dt to this and temperature terms to that side. So friends, after rearranging we get this, and now we integrate from 0 to t and this t initial to t final. Friends, after integrating we get this equation, and now we have everything. H is given, area is pi dl for the cylinder, and we already know the diameter of the cylinder. L is what we need to find out, and m by t is nothing but mass flow rate. This is also given in the equation. T I, T F, T infinity, everything we know. So let's substitute the values. So H, area is pi dl, and mass flow rate Cp, everything was substituted. So for solving for L, in the end we get L is equals to 17.88 meters. Friends, for 63, stress tensor is given and we need to find out tau maximum. For that, we need to find out all the three principal stresses, friends. Here, many of us committed, including me, the mistake of considering this as 2 by 2 matrix and calculating sigma 1 and sigma 2. But if this is different from 130, 30, 30, 50, this is two-dimensional. Here you need to find sigma 1 and sigma 2 and you can find tau maximum. But here you cannot do that, friends. Here you need, because it is three-dimensional stress tensor, we need to find sigma 1, sigma 2, sigma 3 as well. So let's find them. Friends, we can find out the principal stresses by equating the determinant of this vector, this matrix, to 0. So friends, by taking determinant we get this equation, and by solving we get sigma 1, sigma 2, sigma 3. So tau max is sigma max minus sigma min by 2. So our sigma max is 140, sigma min 1 is 0. 140 minus 0 by 2 is 70 MPa is the final answer. Friend, question number 64 is formula based. Variance of error is equals to sum of squares of error divided by n minus 2. So sum of squares of error is given as 2.4 and n is 11. So by solving we get 0.26667. So by rounding off we get the answer 0.3. Friends, for question number 65, there are two phases are in equilibrium. So we can consider isomorphous diagram where two phases are there. So let's see, given for B, here it is A, it is B, and B is increasing. For beta, the equilibrium composition is 90% B. So by that we decided here it is beta and here it is alpha. How? Given beta phase has equilibrium concentration of 90% B. Since this is the axis of increasing B, it is 90%. And alpha, this is what we need to find, friends, and the composition of Li is given as 70% B. Here we are going to use the lever rule. This is for alpha, this is for beta. Given alpha by beta is 2 by 1. Alpha is this, 90 minus 70. So 2 by 1 is equals to, alpha is this, right? So this phase represented by this length and this phase represented by this length. So 90 minus 70, 20 divided by beta is nothing but 70 minus x. So by solving we get x is equals to 60. So equilibrium composition of alpha is 60 weight percentage of B. Friends, if you still have any doubts, join our Metallurgy Crisp Telegram group. You can directly get this group by searching in the Telegram. You can post your doubts in that channel.